Hello friends, this is Gangadhar from the YouTube channel Maths Ganga. So now in this video, I am going to deal with the next questions of the pre-RMO 2018 paper. See, in the last video I discussed the first 4 questions. Now I am starting with the 5th one. Okay. In the 5th problem, the question itself they mentioned that ABCD is a trapezium in which this AB is parallel to CD. This is the given question. And they mentioned that this AD is perpendicular to AB. So here we have the perpendicularity. Okay. And we have an inner circle for this trapezium ABCD, which is touching the AB at Q and CD at P, such that this PC is 36, whereas this QB is 49, and ask us to calculate this PQ. Now this is the question. Okay, right. Now they mentioned the problem that these two are parallel. Since these two are parallel, since this angle is 90, automatically this angle also become 90. And one more thing is, this AB and CD are parallel tangents for the circle. Since they are parallel tangents, if you join PQ, surely this BQ and this point is the center and this PQ is the diameter of the circle. Okay. See, and they ask us to calculate the PQ itself. So we have to calculate this PQ. They may given that this is 36 and this is 49. Since this is 36, from this external point there are two tangents for this circle. So these two lengths are equal. So since this is 36, this is also 36. In the same way, from this external point P, again we have two tangents for the circle. Since this is 49, this is also 49, then the total length will become 49 plus 36. 49 plus 36 is, and then 85. This total length is 85. Okay. And now to calculate this PQ, what we are going to do is, see, you just draw a perpendicular from C to the opposite side. Okay. Since this PQ is diameter and these two are the perpendicular again here. Okay. This is the diameter line and this is the tangent line. So this is 90, this is 90. Okay. And I am drawing a perpendicular, this is also become 90 and this is also 90. So here I have a rectangle. Since this part is 36, surely this is also 36. Since this part is 36 and the total part is given as 49, you get the remaining part is 49 minus 36. 9 minus 6 is 3, 4 minus 3 is 1. So finally what we have? This part has 30 and this part has 85, and we have to calculate this length. This length is directly equal to the PQ length. So here we have a right angle triangle. So the right angle triangle with the measurements 85 and 13 we have. Then by using the Pythagorean theorem, directly you can calculate this length as 84. Since this length is 84, PQ length is also 84. So this is a problem of geometry from the pre-RMO 2018. What it is given? Just once again, if you look at the given ABCD is a trapezium in which AB and CD are parallel such that AD is perpendicular to AB, and they ask us to calculate PQ by mentioning PC as 36 and QB as 49. Since these two are parallel and this circle, this PQ becomes diameter. If you join this PQ surely makes 90 degrees perpendicularity or 90 degrees at this points P and Q. Now, if you draw a perpendicular from C to the opposite side, here also we have 90 degrees, and this PC and this forms a rectangle here. Since this is 36, this is also 36, the total length is given as 49, this part will become 13. Since this part is 13 and this part is 85. How it becomes 85? By observing. It's an external point and these two are the tangents to the circle. If we draw two tangents from an external point to a circle, the lengths of the two tangents are equal. So the lengths of these two parts are equal. Since it is 36, this is also 36. The total length is 85. So this length is 85. This length is 13. We have to calculate PQ, which is nothing but this length. So these three are making a right angle triangle here. From the Pythagorean theorem, we calculate this length as 84. Since this is 84, this PQ is also 84. Okay. So there ends the 5th problem of pre-RMO 2018. Okay. Now let us go to the 6th point. The sixth point is from the algebra. For the sixth problem, they mentioned that a, b, c are the integers which are satisfying that a plus b minus c is equals to 1, as well as a square plus b square minus c square is equals to minus 1. And they asked us to calculate the sum of all possible values of a square plus b square plus c square. That in turn it means we have to calculate the all possible values of a, b, c. From there we calculate the possible values of a square plus b square plus c square. See here we have a plus b is equal a plus b minus c is equals to 1, and a square plus b square minus c square is equals to 1. From this it is clear that a square plus b square is what? From here a plus b is 1 plus c, and from here a square plus b square is minus 1 plus c square. So if you rearrange these two things, we have that a plus b is equals to 1 plus c here, and then a square plus b square is equals to c square minus 1 here. Okay, and if you calculate, if you square the first equation both sides, and then if you do subtraction, c square term will get cancelled. Okay, and then go to the remaining expression which is involving a and b. See, if you square the first equation, we have that a square plus b square plus 2ab is equals to 1 plus c square plus 2c. Okay, and from the second equation, a square plus b square is equals to c square minus 1. And if you do subtraction, what will happen? Okay, minus plus. These two will get cancelled, these two get cancelled, these two get cancelled. So here we have that 2ab is equals to 1 plus 1 is 2 plus 2c. Okay, again you just replace that 2c, that c with what is c here? A plus b minus 1. So if you replace 2ab is equals to, see clearly 2 is get cancelled from everywhere. We have that ab is equals to 1 plus c. So replace that c with a plus b minus 1. Okay, so again this one also get cancelled. So finally what we have? AB is equals to a plus b. Okay, see now we have that AB is equals to a plus b. So we just rearrange them. So okay, AB is equals to a plus b. So from there we are going to calculate the values of a and b. So AB is equals to a plus b. If you send this side, a into b minus 1. Okay, minus b is equals to minus a minus b, right? AB minus a minus b is equals to 0. Since we have here b minus 1, to make this also as b minus 1, I am adding 1 on both sides. So I have that a into b minus 1 minus of b minus 1 is equals to 1. Now in the left side, if you just common out b minus 1, we have that b minus 1 into a minus 1 is equals to 1. So b minus 1 into a minus 1 is equals to 1. The problem itself, they mentioned that a, b, c are integers. Since a, b are integers, see how we will get 1 by multiplying two integers. If both are 1s, then the product is 1. If both are minus 1s, then the product is 1. Okay, in those two cases, we need to calculate the values of a and b. So totally we have two chances for a and b. In the first case, a is, if a minus 1 is 1, a is 2, b minus 1 is 1, b is 2. And in the second case, if a minus 1 is minus 1, what is a? A is equals to 0. And from here also, b is equals to 0. So we have that a is equals to b is equals to 2 or 0. Since a is equals to b is equals to 2 or 0, then what about c? What is c? C, from this c is equals to a plus b minus 1. So c is equals to a plus b minus 1. If you took 2, a plus b, 2 plus 2 minus 1 is 3. Okay, and if you take 0, 0 plus 0 minus 1 is minus 1. So totally we have two chances. A is 2, B is 2 and C is 3 is one chance. A is 0, B is 0 and C is minus 1 is another chance. And they ask us in the question itself, they ask us to calculate sum of all possible values of a square plus b square plus c square. In one possibility, a is 2, b is 2 and c is 3. In that case, a square is 4, b square is 4, c square is 9. 4 plus 4 is 8, 3 square 9, 9 plus 8 is 17. So in one case, if a is 2, b is 2 and c is 3, a square plus b square plus c square is 17. And in the other case, a is 0, b is 0 and c is minus 1. In that case, if you calculate a square plus b square plus c square, you get it as 1. So one possibility for a square plus b square plus c square is 17 and the other possibility is 1. Sum of these two possible values is 18 and your answer is 18. Okay, so it's regarded as an easy problem from the algebra of pre-RMO 2018. Okay, just look it. Then, coming to the seventh problem. See, I am going to deal with the seventh problem. What is the seventh problem? A point P is in the interior of a regular hexagon. It is at a distance of 8, 8, 16 units from 3 consecutive vertices of the hexagon. If R is the radius of the circumcircle of the hexagon, what is the integer closest to R? See, we need to discuss something about the hexagon initially. Okay, there it is mentioned that a regular hexagon. What is a regular hexagon? Regular hexagon is an hexagon, that means a polygon having 6 sides in which the lengths of all the sides are equal. Since it is regular hexagon, all these are equal and this regular hexagon with its center makes 6 equilateral triangles. Okay, all these are the equilateral triangles because the total angle at the center is 360 degrees. It is divided into 60 parts. So all the angles are 60, 60, 60, 60. Okay. And one more thing is, since the regular hexagon, if there exists a circle circumscribing this regular hexagon, so all these parts are the circumradius, capital R. Okay. So everything is an equilateral triangle. All these are equals to the capital R. This is a known thing of the regular hexagon. Now, according to the problem, we need to put a point in the regular hexagon, okay, whose distances from 3 consecutive vertices is mentioned as 8, 8 and 16. Okay, fine. So to solve this problem, I need to give you one more thing. Okay, what it is if it is a regular hexagon, if you observe these 4, okay, see, if you observe these 4 are making what? These 4 are making a trapezium there in the regular hexagon. How it making a trapezium? Since everything is a regular equilateral triangle, the angles at these points are also 60, 60, 60, 60. And if you look, this angle is 120, this angle is 120, this is 60, this is 60. Okay, so this part is a trapezium in the regular hexagon. Okay, and one more task is, see, since an equilateral triangle, the side of the regular hexagon also become equal to the circumradius, capital R. And already we mentioned that this total length is 2R. This is R, this total length is 2R. We have a trapezium like this. This is R and this is 2R. Okay, and we have a trapezium like this. This length is also equals to R. This length is also equals to R. Okay, so this angle is 60, this angle is 120. Sum of these two angles is 180. Okay, if you treat this as transversal, these two will become parallel. Okay, and again the same thing, 120 plus 60. Okay, and one more thing is, all these 4 points lying on a circle, the circumcircle of the regular hexagon. Okay, so that means this shape. Okay, if you name this regular hexagon as A, B, C, D, E, F. Okay, I am taking only A, B, C, F. This A, B, C, F is a trapezium with the measurements like R, R, R and 2R. And one more task is, this ABCF is a cyclic quadrilateral because the points ABCF lying on the circle. Okay, this is the well-known task from the regular hexagon. Now coming to the question, they mentioned that you need to take a point P in the interior of the regular hexagon. For suppose, if you took a point P here, okay, see, for our convenience I am going to draw one more diagram. Okay, see, if you have a regular hexagon, okay, right, this is actually center of the hexagon, and if you took a point P in the regular hexagon, this P, the distance from P to one vertex A is 8 and P to the another vertex B is also 8, and from this point P to this consecutive vertex is 16 dimension. Since it is a symmetrical shape, since this part is 16, automatically this part also becomes 16. So this is 8 and this is 16, this is 8 and this is 16. If you join these, okay, in this trapezium or in the cyclic quadrilateral, these two are acting like a diagonals. So what is the length of this diagonal and what is the length of this diagonal if this point is the given P? Okay, this is 8, this is 16. So this total length is 24. This is 8, this is 16. And again this is 8 and this is 16. Okay, so finally what I am going to tell you is, this is a cyclic quadrilateral, a well-known thing from the regular hexagon, and in the question itself they mentioned that these lengths are 8 and these lengths are 16. So we have the measurements of the diagonal. See, finally since ABCF is a cyclic quadrilateral, then this is enough to apply Ptolemy's theorem of the circles. If you apply Ptolemy's theorem of the circles, the Ptolemy's theorem is product of these two sides, which is 2r square, plus product of these two sides, which is r square, is equals to the product of the diagonals. The diagonal length is 24 now, so 24 into 24. If you solve, 3r square is equals to 24 into 24, so 3 eighths. Okay, and then r square is equals to 24 into 8. Okay, we are going to calculate the approximate value of r. So 24 into 8 means 24 means how much? 8 3 is 24 now. So the value of r is 8 root 3. Since the value of r is 8 root 3, and by replacing the approximate value of root 3, you will get the radius value is approximately, okay, 14. Right? So this is the problem of geometry from the pre-RMO 2018. So the basic rule which is involved in this is the concepts of regular hexagon, and another thing is the rule of Ptolemy's theorem. By applying these two, directly we simplify that the radius is 8 root 3 and the nearest integer for the radius is 14. Okay, there is the problem from the pre-RMO 2018. Another one. Okay, look it.